Hello everyone. Hello everyone. Welcome to this fresh session on electromagnetic fields and transmission line. Today I am going to discuss about the examples on electric field intensity. So today we'll continue with our next example. Here we have to find out electric field intensity at 2, 0, 0. So these are the points given on the x, y and z axis. So for this axis we have to find out the electric field intensity. So let us write down the names. Here we have x, y and z. So on x-axis it is 2. This is 2. Y-axis 0 means same point. On z-axis it is 2. So on this plane, xz plane, on this plane somewhere this point is located, a point Q. There we have to find out the electric field intensity because of some line charge which is lying on the y-axis. That means the line or the conductor. Line is nothing but, for say, conductor. Here conductor is lying on y-axis. So here we will draw, say, one conductor is lying on this y-axis. Say it is having some rho L. So from here it is applying some electric field intensity on this charge Q. So if we draw perpendicular, we can find out the source point and the destination point. Destination is charge Q and the source is the line. So this line is applying electric field in all the region, but we have to find out electric field intensity at this particular charge only. So let us write down the formula for line charge density. For line charge density, E bar is given as rho L, that is line charge density, divided by 2 pi epsilon naught R into AR cap. So let us first find out the R, the position vector. This position vector we can find out as the destination points minus source points. So destination points are 2, 0, 2, because that is the place where we want to find out electric field intensity, minus another points we are considering here is, say, at origin. So from origin we will find out electric field intensity in this case. So what will be R here? R will be equal to 2 AX cap plus 2 AZ cap. So for AR cap it will be equal to R bar divided by mod of R bar. So mod of R bar, from here we can calculate mod of R bar is nothing but square root of 2 square plus 2 square. So this value will be 4 plus 4 root 8. So this AR cap we can write here as AR cap is equal to 2 AX cap plus 2 AZ cap divided by root 8. So in our formula we have some sort of constant, say 1 upon 2 pi epsilon naught. This value is 18 into 10 to the power 9. So directly we can keep it in the formula of electric field intensity. So electric field intensity will be equal to, in vector form, 18 into 10 to the power 9 into 10 into 10 to the power minus 12 divided by 8 into 2ax cap plus 2az cap. So this one, if we calculate this electric field intensity, I will write down the answer so you can tally it with your calci output. So this should be equal to 18 into 10 to the power minus 12 divided by 4 into ax plus az cap. Further, if we simplify it, we'll get 45 into ax plus az cap. So this will be the answer for this question. Let us move to next example. Next example, there are 3 infinitely line charges. So 3 line charges means 3 conductors are given and they are located at 3 different positions. So say we have one conductor with rho L, one second conductor line with rho L2 and third one with rho L3. So and their locations are also given, and we know for line charge what we have. Now here we have to find out D as well as E. Both we have to find out. So it is because of 3 charges. So what will be the total D? Suppose if we want to calculate D total, it will be nothing but addition of D1 plus D2 plus D3. So separately if we calculate them, so what will be D1 equal to? D1 will be equal to, say, rho L1 divided by 2 pi R1 into AR1 cap. So R1 is 0, 0. So and R2 is 3AX plus 4AY. So source points minus destination points, if we do, we'll get R1 bar as 3 AX cap plus 4 AY cap, and mod of R will be equal to 3 square is 9 plus 4 square is 16. So this will be equal to root 25, which is nothing but 5. So AR1 cap will be equal to 3 AX cap plus 4 AY cap divided by 5. From here we can calculate the D1. So D1 will be equal to 5 into 10 to the power 9 divided by 2 pi into 5 into 3 AX cap plus 4 AY cap divided by 5. So after solving this, we'll get D1 as D1 will be equal to 10 to the power minus 9 by pi into 0.3 AX cap plus 0.4 AY cap. So this is D1. Now same way we can calculate D2. So what will be D2 equal to? D2 will be equal to rho L2 by 2 pi r2 into ar2 cap. So with same method we'll find out r2 bar, that is destination minus source. So this one we will get as say 4 ay cap. It will be 4 ay cap, hence mod of r or r will be square root of 4 square, that is nothing but 4. So ar2 cap will be equal to 4 ay cap by 4 is equal to ay cap. So from here, after keeping values, we can get d2 is equal to 4 into 10 to the power minus 9 divided by 2 pi into ay cap. So upon solving, we'll get 10 to the power minus 9 by pi into 0.5 ay cap. Similarly, we can find out d3. d3 will be equal to rho L3 divided by 2 pi R3 into AR3 cap. Okay. So R3 will be equal to 4 AY cap. So destination minus source. So this is destination. So if we minus it, we will get say R3 equal to 3AX cap, and mod of R will be equal to 3. So D3 will be equal to minus 6 into 10 to the power minus 9 divided by 2 pi into 3 AX cap, which will be equal to minus 10 to the power minus 9 pi AX cap. Now our work is to take the total of D total. D total will be equal to addition of D1 plus D2 plus D3. So this total, I'll write down the answer. This total will be equal to minus 0.222 AX cap plus plus 0.286 AY cap so this will be the D, total D, and the relation between E and D is equal to D by epsilon naught. So if we solve this, we should get a value of minus 25 AX cap plus 32 AY cap. So this should be the solution for this example. Now let us see next example. Next example is we have three infinitely long charges, line charges, and they are parallel to z-axis. So this may be the z-axis, and this will be the three lines parallel to the three axes, they are separated by some distance b meter, and rho L is given as 2.0 picocoulomb per meter. Now we have to find out electric field at point P on y-axis. So on y-axis at y equal to some a meters. Here we have to find out electric field. If A is equal to B is equal to 1 meter, what is the electric field intensity? So this is also 1 meter, this is also 1 meter. So for these given distances, we have to find out the electric field intensity. So first of all, let us note down the formula for electric field intensity. E bar is equal to rho L by 2 pi epsilon naught R, say A phi cap. The units are volts per meter. So now first let us calculate EY1, that is because of rho L1. So let us calculate rho L1. So we will calculate say EY1 at point P due to rho L1. So this will be equal to 1 upon 2 pi epsilon naught rho L1 cos theta divided by square root of a square plus b square. Now similarly, we can find out EY2 at the point P due to second line due to rho L2. So that thing will get as 1 upon 2 pi epsilon naught rho L2 cos of theta divided by square root of a square plus b square. Similarly, we can have EY3 at the point P due to rho L3. So this time we will get 1 upon 2 pi epsilon naught rho L3 by A. So rho L1, rho L2, rho L3 are all same. So we can say that one single rho L is nothing but equal to rho L1 equal to rho L2 equal to rho L3, right? So now total EY, if we want to calculate for total EY, so what we have to do, rho L by 2 pi epsilon naught 1 upon A plus 2 cos theta divided by square root of a square plus b square volts per meter. So then we have say cos of theta is equal to a by square root of a square plus b square. So EY will be equal to rho L by 2 pi epsilon naught 1 upon A plus 2A divided by A square plus B square. So this will be the charge. So this is EY. So this is rho L. Now if we simplify it, simplification will get rho L by 2 pi epsilon naught A, and this bracket will be simplified to 3a square plus b square divided by a square plus b square into ay cap. So if what is the condition, a is equal to b is equal to 1 meter and rho L is equal to 2 picocoulombs per meter. So what can we write there? So this will be equal to the electric field intensity will be equal to 2 into 10 to the power minus 12 divided by 2 pi epsilon naught. A is 1, then 3.1 plus 1 by 1 plus 1. The direction is ay cap. So by keeping the values, we can say 2 into 10 to the power minus 12 into 2 divided by 2 pi, which will be equal to 2 into 10 to the power minus 12 ay cap by pi epsilon naught, and the final solution will be 0.0719 ay cap volts per meter. Now let us see one more simple example. Here we have an infinite length uniform line charge density rho L is given. It is lying on z axis. So we have to find out electric field intensity at 4, 3, 3. So if we draw, we can draw it like this. Say this line will make little bit more weight. Okay, so this is say z axis, this is say y axis, and here is our third axis, say x axis. So for this, so say this is z and this is y, this is x. So what he is saying, the infinite line charge is present on z axis, say from minus infinity to plus infinity, and we have to find out electric field intensity at say 1, 2, 3, 4 at x, 3 at y, and some height 3, some point here is here, it may be some point there. We have to find out the electric field intensity. The first step, you will find out r, the distance r will be say, I will directly take modulus, say it will be x square plus y square, that is equal to root 16 plus 9 equal to 5. So formula for infinite line charge is E bar equal to rho L by 2 pi epsilon naught r into AR cap. By keeping the values, we can say 10 into 10 to the power minus 12 into 18 into 10 to the power 9 AR cap. So after simplification, we will get 180 into 10 to the power minus 3 AR cap volts per meter. And if we solve this, electric field intensity will be equal to 180 AR cap millivolts per meter. So this should be the solution for electric field intensity. Now in this session we have covered the electric field intensity due to line charge distribution. In earlier session we have seen single charge. Similarly, we can find out electric field intensity for surface, or we can have problem related to volume. So with this example we will stop here. In next session we will see with a new topic or example. Thank you. Have a good day.